Trigonometric ratio of a right triangle. For any acute angle theta of a right angle triangle as shown in this figure, each side length of right angle triangle as shown in this figure can be found by applying Pythagoras theorem and can be written as a squared plus o squared equal to h squared, where a refer to adjacent, o refer to opposites, h refer to hypotenuse. So it must be noted that adjacent is always next to the angle, while opposite is always opposite to the angle, and hypotenuse is the longest side of the triangle. For trigonometric function of acute angle, the ratio of sides right angle triangle are normally known as a sixth trigonometric function or sine, cosine, tangent, secant, cosecant, and cotangent. It can be defined as below. Sine theta is equal to opposite over hypotenuse. Cos theta equal to adjacent over hypotenuse. Tangent theta equal to opposite over adjacent. Cosecant theta equal to 1 over sine theta, or also equal to hypotenuse over opposite. Secant theta equal to 1 over cos theta, also equal to hypotenuse over adjacent. Cotangent theta equal to 1 over tangent theta, or also equal to adjacent over opposite. The trigonometric ratio associated with the angle of 30 degree, 60 degree, and 45 degree are used frequently. The exact value can be easily obtained using either equilateral triangle and also isosceles right angle triangle. So we can find this. This is 30, 60 degree. The hypotenuse will be 2. Here should be square root of 3, and here is 1. Okay, so this is square root of 2 for 45 degree at the hypotenuse side, and then for both opposites and also adjacent is equal to 1. It is important to remember equilateral triangle and also isosceles right angle triangle in order to solve future trigonometric ratio problem. The summary of the trigonometric ratio are shown in this table, where we can look at here sine theta for theta, where theta equal to 30 degree is equal to 1 over 2, and cos theta for 45 degree is square root of 2 over 2, and tangent theta is for 45 degree is equal to 1. We know that sine theta is equal to opposite over hypotenuse, where if we want to find sine 45 degree, opposite is 45 is 1, and the hypotenuse equal to square root of 2. So if we simplify this, multiply both equal to square root of 2 divided with square root of 2. So we get square root of 2 divided with 2. Therefore, sine 45 is equivalent to square root of 2 over 2 by looking at this table. The Cartesian excess divides a plane into 4 quadrants. First quadrant, second quadrant, third quadrant, and fourth quadrant, where at first quadrant, x and y value are positive, and the second quadrant, x value are negative and y value are positive. For third quadrant, x and y value are both negative, and the fourth quadrant x positive and y negative. Imagine an arrow radiating up from the origin with a length of r and oriented an angle of theta. Then a triangle can be constructed by drawing the line vertically and horizontally to the x and y axis. Suppose the arrow headed is a coordinate of xy. Then to find sine theta, we know that sine theta is equal to opposite over hypotenuse. So from this figure, theta cosine theta opposite over hypotenuse r, therefore we get y over r. And we know that sine theta is equal to 1 over cosecant theta, therefore cosecant theta is equal to r over y. As for cos theta, we know that cos theta equal to adjacent over hypotenuse. So cos theta adjacent equal to x and hypotenuse equal to r. Therefore, we get cos theta equal to x over r. And as to find secant theta is equal to 1 over cos theta. Therefore, secant theta equal to r over x. Then, for tangent theta is equal to opposite over adjacent. So, opposite, which is x, opposite refer to y, and adjacent equal to x. So, therefore, we get y over x. And cotangent theta is equal to x over y. Since we have 6 trigonometric functions, the positive signs of the trigonometric function in the various quadrants refer to this figure. As we look at this first quadrant, all trigonometric functions are positive. As for second quadrant, sine and cosecant are positive. As for the third quadrant, tangent and cotangent are positive. And the fourth quadrant, cosine and secant are positive. Let's look at the example. To find all trigonometric ratio of the following triangle, first we must remember on this formula. And from this triangle, we find that we didn't have a hypotenuse value. So we can apply Pythagoras theorem to find the hypotenuse. So we know that adjacent squared plus opposite squared equal to hypotenuse. So adjacent value is equal to 9, opposite value equal to 6, and we want to find hypotenuse by substituting in this formula. So we get hypotenuse equal to square root of 117. So to find all the trigonometric ratio, so we just can apply all this formula and we get this answer. The same goes to this question, but for this part, we didn't know what is our opposite value. We must know again the formula of a trigonometric ratio and then find the opposite value by applying the Pythagoras theorem. So the formula is substitute at using this value 24 squared plus opposite squared equal to 26 squared. So we get the opposite value is equal to 10 and substitute in this formula to get all the trigonometric ratio. Next example. Now we want to find all sides and angles of the following triangle. The information given that we have one angle and one side, which is the opposite sides for this angle. Therefore, we can use sine theta, where sine theta is equal to opposite over hypotenuse. So we can substitute in this formula. We know that sine theta for this value of angle. But since we have pi here, and I want to use degree for this angle, so we know that theta for pi is equivalent to 180 degree. So divided with 3, therefore we get 60. So it's equal to 6 over hypotenuse. So hypotenuse is equal to 12 over square root of 3. Okay, for the hypotenuse sides, we have 12 over square root of 3. For another sides, we can apply the Pythagoras theorem, and we get the adjacent equal to square root of 12. Next, we want to find this angle. Since we have the information of this angle, so we can easily find this angle because we know that the total of angle in a triangle is equivalent to 180 degree. Therefore, to get that angle, we just know that 60 degree plus 90 degree plus theta A is equal to 180. Therefore, theta A is equal to 30 degree. Now, pause your video and try to do this exercise. For this exercise, we want to find all the trigonometric ratios of the following triangles. Before we start, we need to look at the information given in this question. We find that we have a value of 6, which is the value of the adjacent, and the value of 10 for hypotenuse. So, meaning that we are looking for opposite by using the Pythagoras theorem. So we know that the formula of the Pythagoras theorem is adjacent squared plus opposite squared equal to hypotenuse squared. So substitute the formula, we get 6 squared plus 2 squared equal to 10 squared. So rearranging, we get the opposite is equivalent to square root of 64, or we get this equal to 8. For finding all the trigonometric ratio, so you must look at the formula of this value. This formula you just substitute and you will get sine theta is equal to 8 over 10 or equivalent to 4 over 5. Cos theta is equal to 6 over 10, or it's equivalent to 3 over 5, and tangent theta is equal to 8 over 6, or is equivalent to 4 over 3, where we can also find the cosecant theta, which is equal to 5 over 4, by looking at this. And we can also find the secant theta is equal to 5 over 3, and cotangent theta is equal to 3 over 4. For this exercise, we want to find all the trigonometric ratio of the following triangle. Again, we need to look at the information given in this figure. And we find that we have a value of 5 for opposite, a value of 7 for adjacent, and we want to find the hypotenuse, side, and also the angle. So we can use the Pythagoras theorem to solve this equation. So again, writing the Pythagoras theorem, we have the a squared plus o squared, which is the opposite, equal to h squared, hypotenuse. Substitute the value that we have, 7 squared plus 5 squared. So we want to find h squared. So h, or hypotenuse, is equal to square root of 74. And to find all the trigonometric ratio, again, we need to remember this formula. So by substituting all the information that we have in this formula, we get sine theta is equal to 5 over square root of 74, where sine theta is, is equal to 1 over cosecant theta. Therefore, cosecant theta is equal to square root of 74 over 5. Cos theta, we will get 7 over square root of 74, and we get secant theta equal to square root of 74 divided with 7. For tangent theta, we'll get 5 over 7, and for cotangent theta, we'll get 7 over 5. Now pause your video again and try to do this exercise. For this exercise, we need to find all the sides and also angles of the following triangle. But by looking at this triangle, we know that this is an isosceles right angle triangle because we have a 45 degree here. And for this theta is also known to be 45 degree, since we also know that the total of the triangle's degree is 180 degree. So to find the degree for theta is equal to 180 degree minus 90 degree minus with 45 degree. So we will get theta equal to 45 degree. So since this is a isosceles right angle triangle, we know that the sides of BC, which is this sides, is equal to sides of AB, okay, which is this side. So BC, the sides, is also equal to AB, which is equal to 2. For hypotenuse, to get this value, we just can apply the Pythagoras theorem. So we will get, we want to know the hypotenuse value. So we get 2 squared plus 2 squared. So we will get h hypotenuse equal to square root of 8. So we will get here equal to square root of 8. We also can write this simplified version to become 2 over square root of 2. From this exercise, we also want to find all the sides and angles of the following triangle. From the information given here, we can find the angle of theta A. Since we know the overall total of a triangle is equal to 180 degree, so we just minus with 90 degree from here and 70 degree. Minus with 70 degree, you will get theta A equal to 20 degree. Since we have all the degrees, we also can find, we also have a sides of 6, so maybe we can use sine theta, where sine theta equal to opposite over hypotenuse. So sine theta, theta here opposite, we can use for 70, so sine 70 degree equal to 6 over hypotenuse. So from here we calculate, we will get hypotenuse equal to 6.39. Since we already know the hypotenuse 6.39, we can use the Pythagoras theorem to get the sides of AC. So we want to find AC squared is equal to 6.39 squared minus 6 squared. So we get 4.83. Therefore, AC is equal to square root of 4.83, or it is equal to 2.20. So the same method to find this exercise, we want to find all the sides and also the angles of the following triangle. So we look at here, we have theta, total value of the triangle is equal to 180. So to find theta A, we just minus 180 degree with 90 degree as well as minus with 30 degree. So we will get equal to 60 degree for theta A. And if you want to find the sides. So again, we can use sine theta equal to opposite over hypotenuse. So sine theta, so theta here we use 30 degree because we can know the opposite is equal to 7. And now we can find the value, the length of side for AC. So AC is equal to, calculate, we get AC equal to 14. So we get sides, this side is equal to 14. And then to get this, we can use the Pythagoras theorem. We now find AB squared is equal to 14 squared, which is the hypotenuse, minus with a 7 squared. So we will get this equal to 147. Therefore, for AB is equal to square root of 147, which is equal to, okay, we can just leave the answer like this. For the final exercise, let's say we have this information given. So to look at this angle, if we need to change it to degree, so because we want to know the angle in degree, so theta equal to 2 pi over 9, and we know that pi is equal to 180 and the total revolution equal to 360 over 9. So we know that theta is equal to 40 degree. And to get theta A, and we know that total of triangle, the angle is 180 degree for triangle total, minus with 90 degree, and minus with 40 degree. So we get theta A equal to 50 degree. Again, to complete the sides, we use the sine theta. Okay, so use sine theta here, I take 50 degree. Okay, so we know the opposite equal to, we want to know the opposite, which is the BA, and we know the hypotenuse equal to A. So BA is equal to sine 8 sine 50 degree equivalent to 6.13. Lastly, we want to find BC, the size of BC squared. So use the Pythagoras theorem. Substitute in the formula of Pythagoras theorem. So we get 6.13 squared. We get 26.4231. Therefore, BC is equal to square root of 26 over 4231. So it is equivalent to 5.16.